Welcome to this tutorial on the ReFramework inside of UiPath Studio. You'll notice here I'm currently on our main homepage or start screen as it pertains to Studio, where we would begin all our projects. This particular tutorial or demonstration here is actually going to be slightly atypical from the ones that we've done up until this point, in the sense that it's really not conducive to much of a follow the leader type model, to where it's you're ultimately going to be following along with various tasks that I'm going to be completing. I'm really going on more of a tour guide type of an approach here to walk us through the various components and aspects as it pertains to what the ReFramework is and how all the various components cohesively and collectively work together. So with that said, you'll notice the ReFramework here is under the new from template option here. And what I always try to tell folks here is, when you're at this stage, think about Microsoft Word and how there's various templates that you're able to complete a Word document. So think about memos and cover sheets for fax reports and stuff, et cetera, along those lines. The same notion kind of applies here, in the sense that UiPath as the organization has built a template specifically called the ReFramework. So really what this is trying to say more abstractly is they've already put together a mini automation for us, that really all we have to do is implement the code that's ultimately needed by us, the developer, to make a particular automation execute the way we ultimately desire. It's just a matter of plugging in code, just like you would a Word document template or anything along those lines. So again, up to this point, we've done a lot of work doing new projects via processes here. And just as it implies, starts with the blank projects. What we've seen, there's literally nothing there. It's a fully clean template, or not template, but a fully clean project in which we're able to build everything up from scratch. What we're going to see inside the Robotic Enterprise Framework, again, there's going to be code in here that has been engineered and designed by UiPath, the organization. So in here, normally I would give very meaningful names, make sure that I'm putting information into put my project into the correct or desired folder, and obviously giving a meaningful description. I can't really demonstrate the ReFramework without opening up a new project here. So I'm not going to pay a lot of attention to detail here, just simply I'm trying to get to the template so we can actually visually see and obviously articulate through all the various components. I'm simply going to hit create here. You'll notice the build time here is going to be just slightly longer than what we've seen with the process, and reason being is there are several more files that are ultimately going to be seen and made visible here in just one moment. And this is exactly what I was talking about. Notice on the project tab over here, there are a handful of folders. Two in particular to point out here, you'll notice there's a framework folder, which has a pile of XAML files in here, as well as the data folder here that has a Excel spreadsheet known as config.xlsx. We will be talking about several of these files in depth and detail, and we'll definitely spend some time talking about the config file, which is an extremely important aspect to the overall use as it pertains to working in ReFramework. So with that said, I'm going to open up the main workflow. As always, you can do it straight from the link that's initially provided here, or you can double click on the main.xaml file right in the project tab here. So opening up the main workflow, recall our projects up until this point have always been in totally blank when we get to this point. All of a sudden inside of the ReFramework, you'll notice you're greeted with what is known as a state machine. It looks very daunting, and my goal by the end of our lesson here is to hopefully bring the edge down and really demonstrate that the ReFramework is really not as daunting and intimidating as it currently appears directly in front of us. This notion of a state machine in its most generic aspect, if you look at it, it's really nothing more than a flowchart. And it's talking about the various states in which our automation could potentially be executing in or residing within. And what I mean by that is, where in this current moment in time is the execution currently at? If you look at the diagram on the screen, we've got 4 potential states that we could be in. The initialization state, the get transaction data state, the process transaction state or the end process state. And you'll notice there are the interconnecting flowcharting lines here that will actually demonstrate how application flow and logic works throughout the RE framework here. One of my little pet peeves that always strikes me here is you'll notice all these lines are stacked one on top of another. It's extremely hard to see. Anytime you bring in an RE framework template, it always opens up this way. One of the very first things that I always do is click on success here and just drag it out so we get a little bit more room here. Same thing with business exception. I kind of bring it halfway. So now you can actually see where these lines are ultimately going and where they're ultimately connecting to. And then just so I don't lose any more work, I always save at this moment in time so I don't lose the little change I made right there. Other than that, the RE framework, if we run the automation right out of the get-go, I'm actually going to get a minor error here. And I'll go ahead and do this so you can see. Notice I've made no code changes. This error that I'm going to receive is complaining about the orchestrator queue name not matching with the queue name that I actually have inside of orchestrator. So you'll notice here, get transaction item process ABC queue does not exist. This is actually coming from, and we'll get into some of the details, but you'll notice the queue name here is talking about in config orchestrator queue name. The one spot, obviously this is talking about the config file, which is one of the huge aspects of the RE framework. So I'm going to stop my automation here for just a moment, leave this little state, get back to main, just so you can see this. The RE framework right out of the get-go, I have a queue out there right now called Acme 1 that we created earlier in our project. You'll notice as the config opens up here, this orchestrator queue name, there's where the process ABC queue came from. So like I said, in orchestrator, I have a queue out there right now in my orchestrator defined as Acme 1. You'll need to make sure that this would match whatever your particular queue name is. And if you don't have one, simply create one and have your queue name listed here in the config file. As soon as I save and close close the config file here, by the way, that queue that I've got has no data in it, so we're not going to have a whole lot of process here. But you'll notice when it executes, everything now should run just fine. And the important part here is I have made absolutely no code changes, and the template executes as expected or as desired. But one thing I like about doing this is it actually walks us through the various states of our overall automation. So you notice there's even some log messages that are already out here is what I'm trying to allude to. And these log messages live within certain areas of the overall RE framework in certain states here. And I'll kind of walk you through these briefly now. The killing processes state, notice it's the very first activity that shows up in our output window here. And this always gets people a lot of times. And what it is, you're thinking we're just now starting our automation. Why are we killing processes? And kind of the background to this thought and idea here is before we begin automating any work, we want to make sure that the systems in which we're automating against are completely off and not executing before we turn those systems on to where we're actually going to automate. We want to make sure the system that we are automating in and with is in a completely pristine state. We want to make sure that when we begin our automation, those applications are being turned on for the first time and subsequently asked to perform some type of action, whatever our specific automation needs. This killing processes activity here lives inside of the initialization state of our RE framework. So if I actually go in and double click on initialization state here, it's a little bit confusing. You actually have to expand out this first run activity inside this if statement. When I do that, you'll see that there is a kill all processes XAML file here. So if I open this workflow, you'll notice killing all processes. That's the exact activity that we see outputted to our window here. And as the annotation up here is even trying to walk us through, this is where we would add a kill activity and specify the actual process names that you would see within Task Manager for the automation or the particular application that you want to ensure are no longer running You may have some additional code other than the kill process, depending on the specific needs as it pertains to the automation that you're doing. But again, the goal of this particular file here is to ensure all the applications that you're going to use in your automation are not currently running before the automation officially begins. So again, kind of using my output window here as a kind of step-by-step flow. So at this point, our start state here, we've gone into the initialization state. You saw there was some code in there I kind of glossed over. We'll get there. We'll talk about some of that here momentarily. But following just our outline here, the first major thing that we as a developer needs to do is to go into that kill all process state and ensure that those applications that we're trying to automate against are not currently running. The next item in the list here, you see it says opening applications. So obviously kind of counterproductive. We killed them, but we've opened them. But again, the big takeaway there is we want the system to be brand new execution of all the applications that we're trying to automate against. So this opening application also resides in the initialization state. So if I go back into here again, you'll notice there's the kill all processes that we just did a moment ago, just talked about a few moments ago. If I scroll a little bit further down, you'll see there's another invoked workflow here of init all applications. If I open this particular workflow here, you're going to see the opening applications log message that is sitting here waiting for us. That obviously, again, is talking about the opening application that we're seeing here. As it's talking about here, it's opening applications used to process, our particular workflow. So if you, need to log into a web page or log into a third-party application on the Windows side, this is the location in which that code needs to exist. What applications are you going to automate? Open up those applications. If logging in is required, this is where you do all your initial logging in. You're initializing all the applications that are needed to process. There is no actual processing that happens in this state. This is purely getting the programs up and running and into a usable state. You'll ultimately create some new XAML files here and have those particular activities invoked here. And that's where that particular code is going to reside at. You'll notice those last two have actually gone into two different XAML files. Kind of one quick thing to point out here, you'll notice the framework here is talking about this folder here. So the init all applications obviously is talking about opening up this XAML file here. You'll notice the other one we talked about a moment ago, kill all processes, is right there. Here it is being invoked as well. Those are the two states that exist inside of the init or initialization state. If we go to the output, again, you'll notice it says no transaction data and that the process finished due to there being no more transaction data. But this is alluding to here, and then you'll recall I said that I had no data in my queue. So this is where that's coming from. It's talking about this state here, get transaction data. This particular state here has one sole purpose in life. And what it does is it gets, as it says here, the next transaction to be processed. It's going out to the orchestrator queue and it's trying to see if there is a record that can be pulled into our automation right here. Recall we had mentioned the transaction item here. I'll pull this up. Obviously this looks very daunting. Here's all the variables inside of main. There is one particular record called transaction item, which is a queue item here. Notice there's even an attribute here. It's the item to actually be processed. It's the get transaction data state that is responsible for pulling that record from the queue into our automation, particularly into that transaction item variable. If we get a transaction item, we'll get down here to the process transaction state, which in this particular case we did not. But I point out the process transaction state here is it's obviously not in the output window since we didn't have a record to process. It's really this state though that is the absolute workhorse. This is where all of our core business logic that's needed for the automation to successfully execute. This is where that code resides. So if I open up the process transaction state, you'll notice we're in a try catch block here. But more importantly, there's a process.xaml file. Notice the framework isn't even here. That's how important this file is. This is where the core logic again resides for automation. So that process.xaml lives right next to main in our project window. So you'll notice it right here. If I open up this workflow, you'll notice there's no log messages here. what it's talking about here. Invoke the steps of the process. This is where you'll have, complete this task, this task, this task. All your individual XAML files that are going to be responsible for completing each step of your actual, manual process today for the steps that are being automated. That's where this code goes. This, like I said, I call this a workhorse file. This is where the core logic exists and we'll execute from. So the big thing, again, kind of what we already briefly talked about, we open up our programs in the initialization state, get these systems to where they're needed to be so we can actually begin processing a single record at a time. So once we get down to here, the systems are all logged in, everything's, all go, we've got a record. It's just a matter of processing that single record that was pulled out of Orchestrator. And then we'll talk about the looping structure here in a moment, but I've obviously got one more state that I need to talk about, and that being the end process state. What I always try to think about here is, if we turn an application on or applications on in the initialization state, in their end process state, we want to make sure we turn those applications back off. So leave the environment in the same state and condition it was in before we began doing our automation work. So if we turned on a web browser, make sure you turn the web browser back off here. If you opened up a Windows application, make sure you turn the application back off on this side. This is obviously, you notice there's no out direction arrows from the end process state. This is where code will ultimately cease executing. This is the termination state of our process. If I actually go into end process here, notice it's in another try catch, but if I expand the try out, you'll notice there's a close all applications XAML file here. If I open this workflow, you'll see closing applications. If I go back to my checklist idea I was doing with the output window, you'll notice no transaction data. We talked about that. The very next thing being closing applications. An easy reference to this idea is this close all applications XAML file, again, that lives inside of our main in process state. It's really a sister or cousin XAML file to the init all applications. What I always try to think of here is whatever code you have in init all applications, you should have the opposite affecting code in the close all applications XAML file right here. So again, init in initialization, and then close in our end process. What I mean by that mirroring, if we open the application, make sure we close the application. Same thing web browser wise. If you're logged into applications, some of the code in end process, make sure you're logging out of those applications. Don't just abruptly end or terminate those applications. All right, so let's quickly talk a bit more in depth as it pertains to the initialization state. So we talked about the idea of opening up your programs, closing your applications via the kill process activity. There's another extremely important aspect of the RE framework that we need to make sure is understood. And we briefly talked about it with the config, and notice in the init it talks about reading in the configuration file. The configuration file, as it pertains to its existence inside of RE framework, it's really this simple and at the highest level. The config gets loaded into a dictionary type variable. Remember, dictionaries being a key and value pair. So it's just a matter of specifying the name of the key from the config file and what value do you want to get back out of it. So as I go into the init state here, let me back up again real quick. I double clicked into the initialization state. You'll notice there's an activity here. If first run, I expanded this out just a little bit ago. You'll notice the config is nothing more than a variable inside of main. If I expand out my variables here, you'll notice config, there's the dictionary I was talking about. It's nothing more than a dictionary. It's just another type of variable. People get very intimidated around this notion of the dictionary, but with some of the activities we've done prior, remember you just send in a value or a key and you get a value back. In this case, you send in a string, some text, and you're going to get some type of object variable, or should say object value, back out of the config file. So first things first, in the init state here, you'll notice it says if the config is nothing, so obviously if the config has no information in it, you'll notice it takes us into this init all settings XAML file here. Again, part of the framework, code that has been engineered again by UiPath, and we're just reaping the benefits of having the opportunity and privilege of using it. So in this case, if I go into this workflow, there's a lot of information contained within. You'll notice the very first thing that it does is it initializes, and notice another thing to point out, notice I've now gone 3 XAML files deep. I've gone from main, I shouldn't say that, I didn't go 3, and I went 2, and this was from before. I need to clean this up. That was when we were talking about our close. So main, and then I went in and opened up a init settings here. You'll notice I'm now 1 XAML file in, and you'll notice here the out config is called in that config. That's again wrapped around the arguments here. Notice out always implying an outbound argument, sending data back to main. So if I look briefly at main, you'll notice the import arguments here. This is where the out config is officially populating the config variable that we talked about just a moment ago. This is how that particular dictionary gets instantiated or populated with data, and it's all coming from, again, this init all settings file. I don't want to get too deep into the weeds here, but the main takeaways here is you'll notice it's simply going through the sheets in our config file, opening up the actual configuration file, each sheet, and then it's just going through each row of the various sheets that I'm on. Ultimately, the important part here, talking about loading the out config, there's the key being populated from the name column in our spreadsheet. So if I open up the config again so we can see it, you'll notice there is a column in here called name. See if I can get all this on one screen. There's the name column. And then you notice you have a column in here called value. So in this case, there's the name and then the value getting populated. So when we were looking at the orchestrator queue name a moment ago, when I changed it to Acme 1, notice if you recall, it said in config open parenthesis quote orchestrator queue name end quote, and it converted it to a string. What it was doing in that case was sending in the value Acme 1 as what the queue name is, and that's where it was able to see if there's any actual data in the queue. All this process does is it walks through a record at a time, loading the key and value pairs here. So, maybe a better way of saying name, this would be your key in your config dictionary, and obviously value, talking about the actual value you would get back out. Just so everybody's aware, this is where that config gets loaded right here. Again, for us as the developer, we're not going to most likely have any needs to make changes here. I never want to say never, because I'm sure there's always a possibility, but for the majority of the time, this is not a spot that we're going to be conducting any actual business with. But to make everybody aware, this is how that config file gets loaded. We're all hopefully at this point familiar with how dictionaries work, and it's just a matter of reading the data out of the config and subsequently into the dictionary right here. So why do we have a config? I guess I haven't really answered that particular question. One of the big advantages using the config is preventing us from having to hard code values directly inside of our automation. And what I mean by hard code values, actually, if I go to where it was trying to get data from the queue, if I actually would type in Acme 1 instead of where it says in config, it would work. The logic in that particular case would have no problems with me specifying Acme 1 directly in the get transaction data activity. The problem is, and it'll make a bit more sense when we get into a lot of our future projects, but any of the values that we may need to have loaded into our individual automations, if we hard code those specific details or values in, and for some reason something needs change, or let's say a web address changes, or something along those lines, we actually have to make a code change to our automation in order for those changes to be updated. If you move those values into this config file here, it prevents the need for code changes to be made. So one thing especially if you get into more enterprise level applications, you may have a formal deployment process to where you ultimately send your code into productionalized state. And if you get into that productionalized state, depending on the organization that you're in, it may not be as simple as just making a quick update in production and you go on your way. Some organizations have formal change processes that need to be followed, and that can take time. And in that period of time, your automation may not function correctly because something in the overall environment of your automation has changed. In this case, if all those values live inside of this config file, it's really as simple as making updates to just the specific config values here, and your automation should continue to run flawlessly. So that's really the main value add here, is that it's really about trying to limit the amount of actual hard-coded values that live within our particular automation. So being able to make simple adjustments as needed and necessary, being able to do that here. And obviously, as you make your changes here, the next time your automation runs, those values get updated accordingly based on what we've talked about right here. So that's really the gist behind how the config process works inside of the ReFramework. And again, that's really the major two steps inside the initialization state here. So let's take this down a little bit deeper, slightly, we've talked kind of high level conceptual, we got a little bit in depth obviously in configuration. Now let's start peeling it back one more layer here. So again, we run the automation, we hit the play button, the debug, we run it, it's running server side now. It's a production automation. Start state goes into initialization, we've talked about it, reads the config, and then more importantly, it opens up all the applications that we need to be able to automate against. Why is this important here? And notice there's two different paths that we can potentially get here as we leave the initialization state. We could have a successful initialization, and you'll notice here it's simply saying system exception is nothing. This implies we had no errors occur inside the initialization state. The other obviously being the opposite here, saying we had a system exception, says here is not nothing, so we had a problem. I always like to use an analogy here thinking about NASA and the launch pad. We're getting ready to launch a rocket. We're going T minus 10, 9, 8, counting down. When you listen to those radio, communications, all systems go. Is everything safe for a successful launch of the rocket? It's kind of a similar approach here. Are we in a safe and successful spot that we can launch our automation? Can we begin pulling data from the orchestrator queue and ultimately processing it in our process state further on down the line here, and within process transaction? So if for some reason we can't get the config file read in, there's an issue or a problem there, then we can ultimately abort the mission at that point. So that's where we would have to throw an exception in, and that's where that system exception we were talking about is raised, and we would immediately abort the mission. So think NASA, for some reason system failure somewhere, they're going to scrub the mission. We're going to scrub our automation here by going into the end process state here. But happy path, right? Obviously, we don't want to go down this route. Happy path, all systems go again. We go in and we begin getting our first record from the orchestrator queue. Another point of failure, though, that I want to point out, this idea of raising a system exception error, would be the scenario in which we've obviously added logic here in that init all application state to say, are we to a point all systems go? And what that means is, could we successfully log into all of our applications? Were we able to open up a particular website, get logged into that website successfully to the point we know we can begin doing work? Could we open up a Windows application, and if there's some login capabilities there, get logged in? Bottom line, can we access all the applications that are desired or needed? And if the answer to that question is yes, we can, we don't throw any exceptions and we stay on a successful path, we're able to begin automating work. For some reason, if we can't get logged in, maybe a password expired or something along those lines, we can't get logged into the system. Maybe the system's completely down, we can't even access the environment that we need to automate against. That's where we'll throw or raise an error and abort the mission again and go down the end process state. On the other side, let's stay happy path now. Successful path. All applications were able to be logged into. Config was read. No issues in the initialization state. All systems go for launch. We're now launching using the NASA type analogy here. We move into the get transaction data state. Again, this one, if I open it up to poke around real quick, One particular item to note here, you'll notice there's a check stop signal activity here. And this one really is engineered around once you move your automations onto a server type deployment, you're running these applications through Orchestrator. There's a button inside Orchestrator that allows you to terminate an automation. It's checking that value to see, was a stop signal sent? Should we terminate the current executing automation? You notice this is simply looking at a Boolean value here. Should we stop, yes or no? It's an if statement here. And if we say yes, we should stop, you'll notice all it does is it turns transaction item to nothing. So remember, transaction item, we're going to see here in just a moment, is the main item that keeps us looping through one record at a time. On the other side, if the should stop was not selected, you'll notice it moves into the get transaction data state, which is another file within the framework. It's this particular activity here, this workflow, that is responsible for ultimately loading the transaction item variable. So if I look at my arguments here, amongst several other arguments as well, but the important one ultimately being, again, transaction item here. So you notice it says out transaction item, setting the queue or setting the transaction item variable. So it's the opposite here. It says equal to nothing. If there is data to be pulled from the queue, that's where transaction item will have data, and it'll keep us inside the loop. And you're going to see that here in just a second. But to poke in real quick, just to see, there's not a lot that goes on in this particular XAML file other than the get transaction item here. And this is where we saw the failure a moment ago before we renamed the orchestrator queue name in our config at the very beginning of our tutorial lesson here. But right here, this is where it knows what queue to get the data from. It's simply checking here, is there data to be extracted from the queue? If so, give me one and only one record. That's the important takeaway here. You only process a single record at a time per process using ReFramework. Notice here of transaction item, there's where the out transaction item gets populated and subsequently passed on back to main and populating the transaction item queue item variable. And then you'll notice we've got a couple other fields down here that aren't as critically as important, just an awareness item to say, notice there's an out transaction item ID that's really doing just a time date stamp here, or a date time stamp, I should say. And then you'll notice there's string.empty. So there's two empty strings, field 1 and field 2 down here, that you're able to go into. If for some reason your automation requires additional information, just understand that these attributes and properties, really variables, are available for your utilization. So this would be one of the rare spots that you could potentially make additional code changes. Again, all dictated and warranted based on your particular automation. So bouncing back out of here, so that's how the data gets loaded into our automation. But again, the key thing to take away from the get transaction data state is working with this transaction item variable here that obviously is going to be passed back to, that's ultimately, I shouldn't say passed back to, but is contained within main. The idea of the data getting passed back to main coming out of our get transaction data state here. So hone in on this transaction item, extremely important variable in our overall automation. If I go back up to the main state machine here, you'll notice leaving get transaction data state, there's two different paths. We've got a new transaction, and you'll notice the condition up here is saying if we have any data in transaction item, so equal to not nothing, meaning it contains data, obviously we need to process it. We need to actually, again, this is the workhorse, we need to actually do the automated task as developed, or as we will develop. Hopefully this one's kind of obvious. If we have no data, transaction item is nothing. So recall, if we hit the stop button, it does a kind of a forced stop here. It sets that value to nothing, sending us directly into the end process state. So at that rate, if we have data, we move into process transaction. There's three states or three possibilities that come out of here. The obvious one that we desire the most being the success state. And you'll notice, or I should say success transition here. And if I hover over it, you'll notice it says system exception is nothing and business exception is nothing. That means we have no exceptions whatsoever with the process that we just went through. Life is good. The record was successfully processed as designed, as intended, we're on the happy path. The record was fully automated and processed. You notice as it does that, if everything was good through our processing here, it simply points us back up to the get transaction data state where we just saw a moment ago. It goes out, attempts to get an item out of the orchestrator queue, and then subsequently go back in, process the transaction if there is a record to be processed. If for some reason that was the very last record we processed, no data will be in the queue. We get the transaction item as nothing, and we'll terminate our automation on the other side. Unfortunately, not every record is able to be processed successfully as desired or intended. And that's where we then run into business rule exceptions and application level exceptions. And you'll notice these two both go to two different spots. A business rule exception simply goes back and grabs another transaction item out of the queue if one exists. And the application exception, you'll notice, comes all the way back up and attempts to go through the initialization process again. Let me try to elaborate on these two states here. Specifically, a business rule exception first. So if for some reason we're in the midst of our processing here, we run across a scenario in which the particular record we are currently attempting to automate or process through encounters some type of situation that it's not critical in nature. It's not detrimental necessarily to the overall process of all of our records, but it's in some way or shape or form detrimental to the particular single record we're processing. That's where you'd want to throw a business rule exception and simply move on to the next record. An example of this, what I always try to demonstrate or talk about here would be, think about screens that you're looping through. You're processing one record after the next record after the next, and 95, 98% of the time, all the values appear right on the screen, right where you expect, and your selectors are working perfect. But then all of a sudden you land on a that exception record, obviously business rule type exception record here. For some reason, a value that you need in order to complete your automation just isn't present on a screen right now. What do you ultimately need to do? Your bot doesn't know how to handle that type of logic. Us as humans, when that occurs, usually we know what the alternative paths potentially are to move from, the value's not here, but I know if I go to these 2 or 3 other screens or 2 or 3 other systems or applications, I could potentially, resolve the problem or scenario. Obviously, you can attempt to build all that logic. It may not be feasible depending on the amount of time that you have available to fully build out your automation. It may just be a case where if that value that is desired or expected on the screen just isn't there, the way that the other majority of the records are, you can mark that record, kind of set it off to the side, and potentially allow human intervention to come in on those particular records that might require the additional level of logic, detail, etc. It's hard to describe, obviously, without a particular example at this point in time. But think about your particular automation. Where is that line going to be drawn to what the bot is able to do, as opposed to where the human might potentially have to step in and augment whatever that work might ultimately be. And that's what we're getting at with the business rule exception. It's a case where a record is being processed that for some reason or another, the value that we need is not on the screen. Maybe a part of the screen or application is unable to load for this single specific record. Scenarios like that, we would tag those with exceptions. We would throw an exception, which would be caught in part of the overall process transaction state, trigger out a business application or business rule exception here, simply move on to the next record and ensure that we're not getting hung up on that one record that we're unable to process. On the other side of the coin comes in this application level or system level exception. And the way I try to describe a scenario like this, notice we're in process transaction again. Let's say in the midst of processing a particular record, say the system that you're automating against goes down. You lose your network connection for some reason, or the application fails, and it's unavailable for any user. Obviously, your bot being, quote, a user, if that system completely goes down and becomes unavailable in the midst of processing our transaction, we have logic here that allows us to go back up and attempt to reinitialize the entire environment. Let's attempt to log ourselves back in. So think application failure here. Major catastrophic problem. We can't continue to process the record we're currently processing. And obviously, we're probably in a more severe state that we can't process any records at this point. The bot's completely lost, the system's down. That's where we raise or have the system raise, the true application level exception. We come back up, in this case, to initialization, where we can attempt to relaunch all the programs again, relog into the systems. If we're in a truly system down state at this point, the initialization state's going to ultimately fail. And recall what we talked about, the idea of scrubbing our mission. If we're truly having a system outage type area these systems can't get logged back into, we're going to raise that system level exception here. And at that point, abort the overall process. On the other side, let's say the system momentarily was down and we're back up here initializing. If it's able to get logged back in, then that's where we'll dive ourselves back through and attempt to process that record again. And that really is the major takeaways as it pertains to the overall environment as it pertains to the ReFramework. Again, kind of in closing and summary, you want to start all your applications in the initialization state here. Again, specifically in the init all applications that you would see inside of here. So turn those applications on that you need to automate against. As you do that, think about the ones that you're opening. Immediately come over here to in process state and our close all applications and reverse that process. Terminate those applications that we opened up, log out of those applications, and then terminate them to be a bit more precise. Once you have that logic up and running and going, then come in and actually build the logic that's needed for your particular automation. And then obviously, one thing that I just realized as I'm talking through this obviously is set up in more of a performer bot point of view or perspective. And the reason I say that, performer bots are responsible for getting the data out of the queue. That's what this get transaction data state does. When we get into building dispatcher bots, we don't have a need to get data. So what I typically do here, if I want to build a dispatcher bot and build it inside ReFramework, what I'll do, and we'll actually go through this in some of the project work activities that we'll do here next. But what I'll do is I'll move the successful state from the initialization down to process transaction. And I will move the success behavior out of process transaction into in process transaction. And then simply delete the get transaction data state. Again, doing this and what I'm describing for a dispatcher bot. We don't need to get data, so this state here in a dispatcher bot is not needed. So hold that thought and idea as we dive into some of the project work. We'll actually go through an example and have a bit more of a contextual definition as to how that works. So hang on to that thought. That'll be coming up in our next set of conversations. So without further ado, that is the overall discussion as it pertains to the ReFramework.